Hello students, welcome to CREATA classes. I am Gurmeet Singh and also welcome you to the probability series. Yes, this is the probability series and this is the second lecture. In this lecture, we will cover all about the probability. Before that, we have covered the basic of the probability. In this lecture, we will cover the formula and the special cases. Special cases, the cases which involve the coin and also the rolling of the dice. Everything we will cover in this video, and we will go very deep into the concept of the probability. After this lecture, you will be able to solve most of the question. After this, we will take down the question series, the various exercise question and the example question of NCERT. So without taking any further time, let's start the lecture. Best of luck. This is the formula of probability. P, E in the bracket is equal to the number of outcome favorable to E upon number of all possible outcome of the experiment. Here on the left hand side we have P and E in the bracket. In the previous lecture we have also done this. Here P symbolizes the probability and E symbolizes the event. The various events that we have covered in the previous lecture are the probability of getting rain on Monday, the probability of winning the match between India and Australia, either 50-50%. All these are the events that we have covered in the previous lecture. So here PE symbolize the probability of happening of that event. So suppose if we toss a coin, we are either getting head or tail. Suppose we have to calculate the probability of getting the head. Getting the head is the event. So in the bracket in place of E, the event will come, that is probability of getting the head. Suppose we have to calculate the probability of getting the tail, then the event will be tail, that is probability of getting the tail. Suppose we are rolling the dice, we can get either 1, 2, 3, 4, 5 or 6. All these 6 output are the 6 event of rolling the dice. So we can either get 1 or we can get 2, 3, 4, 5 or 6. Suppose we have to calculate the probability of getting the number 2 in rolling the die. So that will come in the bracket, that is the probability of getting the number 2 in rolling the dice. Similarly, all the event will come in the bracket. This nomenclature is very important and you should know it. So we have done the left hand side, let's move to right hand side. We will start with the denominator. Here in the denominator, it is written as number of all possible outcomes of the experiment. Here the term experiment is used. Experiment means, for example, tossing the coin or rolling the dice. These are the experiment. In the experiment, we are getting the various output. These outputs are known as events. For example, if we do the experiment of tossing the coin, we can get either head or tail. Head is event, tail is event. Another example, if we are rolling the dice, that is an experiment. In the experiment of rolling the dice, we are getting 1 to 6. We are getting 6 outputs or we are getting total 6 events. So in the denominator, we will get total number of all the possible outcome of the experiment. Rolling the die, we are getting total 6 outcome. We cannot get 7, 8, 9 or 10. We can get only 1, 2, 3, 4, 5, 6. That is 6 outcome. So in the experiment of rolling the dice, we will get total 6 in the denominator. In tossing the coin, we will either get head or tail. That is 2 outcomes will be there. So 2 will come in the denominator. Got it? What is denominator? That is number of all possible outcomes of the experiment. Let's move to the numerator on the top. Here it is written as the number of outcomes favorable to E. E is the event. So all the possible outcome of the event that we want to calculate the probability. Suppose we are calculating the probability of getting head in the experiment of tossing the coin. So the favorable outcome will be only one. Either we will get head or tail, and we are calculating the probability of getting the head. So we can get only one favorable outcome. Similarly for the tail too. Got it? Let's take the example of rolling the dice. Suppose we have to calculate the probability of getting the number 2. So in the experiment we can get the number 1, 2, 3, 4, 5 and 6. And the favorable outcome that we want is number 2. That is only 1. Got it? So in the numerator will be 1 for the event of getting number 2 in the experiment of rolling the dice. Getting the fundamental, don't get confused with the number, why it is 1 or 2. Just understand what the formula is. When we take the various cases and the questions based on the probability, you will understand those numbers. Just understand that on the numerator it will be the favorable outcome of that event. On the denominator it will be the total number of events of that experiment. So we have done the basic formula of probability. Let's take the famous cases of rolling the die and tossing the coin. We will start with the tossing of the coin. So this is the standard coin and also the standard case of probability, that is tossing the coin. Okay. So if we toss the coin, what are the total outcome that we can get? We can get either head or we can get tail. We cannot get the third outcome, that is head or tail. In the standard scenario it will be head or tail. So let's calculate the probability of getting the head and also the probability of getting the tail. In the probability of getting the head, what will be the denominator in the formula? The denominator is number of all possible outcome of the experiment. Here what is the experiment? The experiment is tossing the coin. So we can get tail or head. So the number of all possible outcome is 2, that is head and tail. So in the denominator 2 will come, and what will come in the numerator? It will be 1. Why? Because we only want head as the event. So the favorable outcome to our event, that is getting the head, is only 1. So the probability of getting the head in the experiment of tossing the coin is 1/2. Similarly, in case of the tail, it will again be 1/2. Why? Because the denominator will be same, that is the total outcome will remain 2, head or tail. In the numerator, the favorable outcome of getting tail is only 1. If we toss the coin, the possibility of getting the tail is only 1. So our answer will be 1/2. Got it? The probability of getting the head is 1/2 and the probability of getting the tail is 1/2. In other words, we can say it is 50%. The probability lies between 0 to 1, and 1/2 is 0.5, that is between 0 and 1, that is 50%. So the probability of getting the head is 50%. The probability of getting the tail is again 50%. I am repeating this concept again and again so that it goes directly to your subconscious mind. That is important. Believe me, this will be helpful to you. So just stay with me and understand the concept and just have a fun. Okay? Let's move to the case of rolling the dice. Here let's calculate the probability of getting 1 as an event in rolling the dice. Firstly, let's see what are the total number of all the possible outcomes of the experiment, that is the denominator, in rolling the die. Just take some time, pause the video and think over it. Okay, welcome back. The number of all the possible outcome of the experiment of rolling the die will be 6. We can either get 1, 2, 3, 4, 5 or 6. So all the total possible outcome is 6. Got it? So in the numerator, the number of outcome favorable to our event, that is getting number 1, is only 1. Out of these total 6 events, our event, that is getting the number 1, is only 1. So in the numerator it will be 1. So probability of getting number 1 in rolling the die is 1/6. Similarly, the probability of getting the number 2 is 1 by 6. Why? Because out of total 6 event, our number 2 is only 1. So probability of getting number 2 in rolling the die is 1 by 6. Similarly, for the number 3, it is 1 by 6. For number 4, 5 and 6, it will be 1 by 6. Okay, got it? These are the very basic cases, you should know it. Based on these cases, we will develop the different scenario, but the basic fundamental will remain the same. Okay? Let's move forward and observe the various observations that we can get out of the formula and the two cases that we have done. Let's take both the cases side by side. Here, if we add the probability of getting the head and probability of getting the tail, we will get the number 1. That is 1 by 2 plus 1 by 2 is equal to 1. Here in the practical term, it means that what is the probability of getting head or tail when we toss the coin? When we toss the coin, we will either get head or tail. So the possibility of getting head or tail when tossing the coin is 100%. Here this 100% is symbolizing the same. That is, whenever we toss the coin, we will either get head or tail. That is 100%. Got the point? Similarly, in the case of dice, if we add the probability of getting the number 1 plus the probability of getting the number 2 plus the number 3, number 4, number 5 and number 6, we will again get 1. That is 1 by 6 plus 1 by 6 plus 1 by 6 up to the 6th term, we will get the number 1. Here if we compare this to the concept we have discussed in the coin, here this 1, the addition 1, or we can call it as 100% probability. It means that whenever we roll the dice, we can get either 1 or 2 or 3 or 4 or 5 or 6. That is 100%. What is the probability of getting either 1, 2, 3, 4, 5 or 6? The probability is 100%. Whenever we roll the die, we will get any of the one number out of the 6. This 1 or this 100% is symbolizing the same, that is 100% probability. So we can get our first observation, that is, if we add the probability of all the event within that experiment, we will get the number 1, that is total 1. Here probability of getting the head is 50% and probability of getting the tail is 50%. If we add both the probability, we will get the probability of 100%, that is 1. Just observe that we have to add all the probability within that experiment. We cannot mix match the various experiment. Here the probability within the experiment of tossing the coin are 1 by 2 plus 1 by 2. And the probability of within the experiment of rolling the die is 1 by 6 each. So note that that is within the experiment, and we have to add all the probabilities of all the possible outcome. In rolling the dice, we are having total 6 outcome. We are having 6 events. So probability of all those 6 events will be equal to 1. Got it? This observation is very important. If we add all the probabilities within that experiment, it will comes out to be 1. So this is our first observation. Let's move to the second observation and the last observation. This concept is called PE bar. Bar over the PE. We have seen PE as the probability of the event, and PE bar is the probability of not happening of the event E. PE is probability of happening of that event, and PE bar is probability of not happening of that event. The concept is that the addition of PE and PE bar is equal to 1. That is, PE plus PE bar is equal to 1. Let's try to understand how we get this formula and what is the concept in this formula. Suppose the event is getting the head when we toss the coin. So the probability we will write as probability of head, that is PE, and PE bar will be probability of head and bar over it. It means that what is the probability of not getting the head when we toss the coin. Suppose we are tossing the coin, we are getting head and tail. The probability of not getting the head will be the probability of getting the tail. Are you getting this? The probability of not getting the head is the probability of getting the tail. So we can write probability of head bar is equal to probability of tail. And we know the sum of all the event probability is equal to 1, that is probability of head plus probability of tail is equal to 1. Can we replace the probability of tail with probability of head bar? Here in the journal term we can rewrite it as P in the bracket plus PE bar is equal to 1. That is our formula. Probability of happening of the event plus probability of not happening of that event is equal to 1. This is very important concept and you should know it. This will not be only used in the exam but in the future competitive exams also this is very important. We can also rewrite it as PE bar is equal to 1 minus PE. Both are same, just we have rearranged some of the terms. Got it? So this is the concept. Let's try to understand this in terms of numbers. The probability of head we have seen is 1 by 2 and probability of getting the tail is 1 by 2. So the probability of not getting the head, that is P head bar, is equal to 1 minus 1 by 2. That will comes out to be 1 by 2. That is equal to probability of getting the tail. Are you able to link both the concept? That is the same concept. Probability of not getting the head is 1 by 2. That is equal to probability of getting the tail. While tossing the coin we are getting head and tail only, that is 2 events only. So this concept is looking slightly simple, but when the number of event is more than 2 then the concept becomes slightly tricky and these formula are really useful in solving the complex question. Let's take the experiment in which we are having more than 2 events, that is rolling the dice. Again we are having a dice and it is having total 6 event, getting 1, 2, 3, 4, 5 and 6. Now the fundamental is that what is the probability of not getting number 1 when rolling the die. So again we will denote it as P1 bar. It means that probability of not happening the event 1. Okay, let's again use the same concept. We know addition of all the probability is equal to 1, that is P1, 2, 3, 4, 5, 6 is equal to 1. Can we say probability of not getting 1 is, we can get 2 or 3 or 4 or 5 or 6. Okay, probability of not getting the 1 is probability of getting 2 or 3 or 4 or 5 or 6. That is probability of 2 plus probability of 3, 4, 5 plus 6. Addition of all this will be equal to probability of not getting event 1. Can we replace all these 5 terms with probability 1 bar? We can write P1 plus P1 bar is equal to 1. That is addition of PE plus PE bar is equal to 1. Again we have reached the same conclusion, that is addition of PE plus PE bar is equal to 1. Let's try to connect this with the help of the numbers. The probability of getting 1 is equal to 1 by 6 that we have just seen. So with the help of the formula, can we say probability of not happening of the event 1 is equal to 1 minus probability of happening of the event 1, that is 1 minus 1 by 6, which is equal to 5 by 6. So probability of not happening of the event 1 is 5 by 6. Let's try to reach using the simple method. Here P1 bar is equal to P2 plus P3 plus P4 plus P5 plus P6. And we know value of all this probability is 1 by 6. Let's add 1 by 6 plus 1 by 6 up to the last term. We get 5 by 6. And both are matching, 5 by 6 and 5 by 6. So we can say our observation or the fundamental is totally correct. Okay, we have proved using the two different methods. And we have also used two different concepts, that is tossing the coin and rolling the dice. So we got the concept PE plus PE bar equal to 1. For the time being, just understand this concept and just go to the basic. When we take down the question, you will further understand it more. Okay? So students, we have done with this lecture. But one important thing that you should know. After this lecture, we will take down the next 5 lectures as the question series. Note that if you want to excel or do the mastery on the probability, do the question series and again come back to this lecture. Because some of the concept you may feel be slightly difficult, but after you do the question series, if you come back and do the theory, all those concepts will be clear. So my advice to you, just come back to this lecture after completing the next 5 lecture on the question series. It will be really helpful. So that's it for this video. Best of luck and meet you in the next lecture in which we will take down NCERT example questions. Bye for now. Have a great day.